Now we have some more quadratics revision. The first question we have here, find the equation for the parabola which has a turning point of 2 and -3 and passes through 3, 6. So what we would do is we'd start off with our turning point form equation. Y is equal to, we don't know what the shape of it's going to be, so we'll just put a little a at the front there. And then for our turning point equation we'll go x, and we've got a positive 2, so we'll make that negative inside the bracket, so that should be -2 squared, and then take away 3 goes outside. Now what we need to do is we take our coordinates and they get substituted into the equation. So y is equal to 6, 6 is equal to a x minus 2 squared, take 3, and we would need to substitute our x value of 3 into there, of course. 6 is equal to a 3 take away 2 squared, take 3, and we need to find the value of a as we go through this. So solving the bracket first, 3 take away 2 is 1, 1 squared is 1, so that tells us that 6 will be equal to a take away 3. Then if we add 3 to both sides to leave a on its own, 6 plus 3 is 9, will be equal to a. That will now tell us that our equation will be y equals 9 x minus 2 squared, take away 3. And that's the equation for that. Now moving on to what we have here, find the equation of a parabola which has x-intercepts of -1 and 2 and passes through the point 3, 6. So in this instance here we'll set up 2 brackets, so we have y is equal to 2 brackets, one representing each of the intercepts, so that will be x plus 1, x isn't very good, and another one, x minus 2. Now if you forget how that works for the x-intercepts, so we have x is equal to -1 in the first instance. What we need to do is to set that equal to 0, so we would add 1 to both sides, which would tell us x plus 1 equals 0. That then becomes the first bracket here, and we'll do the same with the 2, and that's applying it. We make that part of the null factor theorem. We're doing that in reverse. We don't know what the shape factor is, so these coordinates here will tell us the shape factor. So we'll put a little a in the front there. Now what we need to do is to substitute 3, 6 into there. So y is equal to 6. Hang on. Let me start that line again. Y is equal to 6 is equal to a, x is equal to 3, and 3 take away 2. So 6 will be equal to a times 3 plus 1 is 4, and 3 take away 2 is 1. So therefore 6 is equal to 4a. And if we divide both sides by 4, a will be equal to 6 over 4, which is equal to 3 over 2. Therefore, our equation will become y is equal to 3 over 2 x plus 1 and x take away 2. Now moving on to the next question. A farmer wants to make a rectangular enclosure using an existing straight fence as one of the sides and materials for an additional 500 metres of fence for the remaining 3 sites. Find the dimensions of the enclosure with the maximum area. Diagram for questions like this always comes in handy. So we have an existing fence, and we then want to make a rectangular enclosure with 3 other sides. As we do this, we don't know what the dimensions of those are going to be, so we can call this side length x, and this one would also be x. We're told that we have 500 metres of fence for the remaining 3 sides, so this side here would be 500 take away 2x. If you work that out, 500 take away the 2 shorter lengths, 500 take away 2x is the length of the other side. So for the area is equal to length times width. So our equation for area will be equal to x multiplied by 500 take away 2x. I can factorise this. 2 is common to both terms inside the bracket there, so I'll bring a 2 out the front of that. A will be equal to 2x, 250 take away x. Now, to work out where the maximum is going to be, we could use the symmetry of the equation. The maximum is going to be halfway between the 2 x-intercepts, if you like. So we can apply the null factor theorem. From this part here, we have an x-intercept of 0. And from this part here, we have 250 take x equals 0, or x equals 250. So halfway between those 2 points will be where our maximum occurs. So the maximum occurs at x equals 125. That would then mean for our dimensions, if we have the shorter length is 125, then the longer one is going to be 500 take away 2 lots of 125. 2 lots of 125 is 250, so 500 take 250 is equal to 250. So the dimensions would be 125 metres times by 250 metres. So a length of 250 and a width of 125. That's the answer to that question. And we'll move on to the next question. Find the x-intercepts of the following equations. So what we would need to do with the first one here is to factorise it. So if I was to factorise this, what are factors of positive 2 which add up to 3? That would be 2 and 1. So we end up with 2 brackets, x plus 1 and x plus 2. We apply the null factor theorem to this, so we set each one of those brackets equal to 0. So if x plus 1 is equal to 0, therefore take away 1 from both sides, x will equal negative 1. Similarly, if we have x plus 2 equals 0, take away 2 from both sides, we have x equals negative 2. So our 2 x-intercepts for this one will be at negative 1 and 0. I'll rewrite that one again. One day I'll get used to this little stylus pen thing. So negative 1 and 0. And negative 2 and 0. So that's the answer to the first one. I'll just put a little box around that one. For the second one, we also need to factorise this, and this looks like it'll be a difference of 2 squares. 3 squared take away x squared. Now if you remember the rule for a difference of 2 squared, if we have a squared take away b squared, to factorise that, it's equal to a take away b and a plus b. So we can apply that little rule to our equation. So we'll have 3 take away x and 3 plus x. And again, with the null factor theorem, we're going to set each one of those brackets equal to 0. So if we go 3 take away x equals 0, we'll add x to both sides in this case here, so we'll have x is equal to 3. And for the second bracket, we've got 3 plus x equals 0. And we'll take away 3 from both sides, so that'll give us x is equal to negative 3. So our two x-intercepts will be at 3 and 0, and at negative 3 and 0. And for the third one of these, what I'm going to do is expand out this first bracket. So y will be equal to negative, x takes 6 squared, so it'll be negative x squared, take away 2 times 6 is 12, x plus 36, and then plus 10. So that first bracket, this bit here, is just the expansion of that. We've kept the negative out the front. Now we'll apply the negative to that first bracket. So we have negative x squared plus 12x, take away 36 plus 10, and this will be equal to negative x squared plus 12x, take away 26. The next thing that I'll do is apply this to the quadratic formula, which x equals negative b plus or minus the square root of b squared, take 4ac all over 2a, where a will be equal to negative 1. So a is equal to negative 1, b is equal to positive 12, and c is equal to negative 26. So if I apply that to the equation, we'll have negative b is negative 12 plus or minus the square root of b squared will be 12 squared, take away 4 times a is negative 1 times c is negative 26 all over 2 times a is negative 1. So x is equal to that, which will be equal to negative 12 plus or minus, let's simplify. We've got 12 squared is 144. 4 times 26 is 104. Now, is this going to be positive or negative? So we've got a negative plus another negative, times a negative is a positive, times by another negative is a negative, so it'll be take away, all divided by negative 2, which will give us negative 12 plus or minus 144 take 104 is 40 over negative 2, which equals, if we simplify that root 40, 40 is equal to 4 times 10, which will give us 2 root 10, so that'll be negative 12 plus or minus 2 root 10 all over negative 2. And these 2's will cancel down to leave us with a 6 there and a 1 there. So let me just shrink this a little bit. It's a little bit crooked. Can't let you look at something crooked, can we? Okay. So now we have, and we can cancel down the negatives as well there, can't we? So we have the negative cancels there, and we've got the plus or minus. So you have to remember that you cancel it both ways. I've just drawn everywhere all over it. So this will end up with negative 12 divided by negative 2 is positive 6. And if we've got a plus or minus, we're still going to end up with a plus or minus. So that'll be plus or minus the square root of 10 in that case there. Now, if you weren't sure about what I did with that root 40, to simplify that, square root of 40 is equal to the square root of 4 times 10. We need to look for a perfect square that goes into 40, which is the biggest one is 4. That will be equal to the square root of 4 times the square root of 10. Square root of 4 is 2. And we can't simplify the square root of 10, so we leave it as 2 root 10. That's where that simplification came from before. Okay, let's move on to the next question. What are the coordinates of the turning point in each of the following? Now these actually should all be in turning point form. So I've forgotten to put the little squares on here. That's better. Okay, if they're in turning point form, we'll take the negative of what's inside the bracket there. So x will be equal to negative 4. And we take the value which is outside there, so negative 6. So the turning point for the first one is negative 4 and 6. For the next one, do exactly the same thing. We've got the negative of what's inside the bracket, so this will be positive 6. And take what's outside the bracket, and that'll be 4. Next one down, do exactly the same thing. So take the negative of what's inside the bracket, so that'll again be positive 6, and what's outside the bracket is plus 10, so it goes up by 10. Wish they were all that easy. And that's the end of this little session.